Hello everybody and welcome back. Welcome back. We're looking at question 15 now on our 2018 Cayley. In the diagram, triangle PQS is equilateral. Okay, so we've got that triangle down here. Also, PQR and PSR are isosceles, and we have the equal sides named. So we've got a lot of the same side length being used. If angle RPQ equals angle RPS, so RPQ and RPS, the measure of QRS is, okay. So, let's just copy our picture over. Q, oh no, it was R at the top. R, P there, Q there, and an S there. Doesn't really matter the names. I don't think I'm going to use them a whole lot. What we want is just this top angle. Okay. Well, first thing to note, if it's an equilateral triangle, we've got 60 degrees, 60 degrees, 60 degrees. Okay. We also have the same angle. I don't know what angle it is, but we could call them both X. And we're told that these two angles here are the same. Well, look at that. We've got a full 360 degrees, so 60 plus 2 copies of X must be 360 degrees. 2X is 300. So X is going to be 150. So 150 degrees. And then, well, it's isosceles. We've got these two lengths are the same, which means the opposite angles are the same. Same down here, because these are really congruent triangles. Because we've got the same angles and the same side lengths. Okay, so we might call this Y. Okay, now the angle that we want is 2Y. So if we just figured out Y, we'd be all set. But we don't even need to do that. We know that 2Y, just looking at this triangle here, plus X, that is to say 150, that's the sum of the angles inside a triangle, so that's 180. So 2Y must be 30. Okay? So you could solve and say, Y is 15, but doesn't really matter. We want to find 2Y. Why bother figuring out Y when we already have 2Y right there? It's 30. Another way you could do the question that sort of just struck me, if you know a lot about circles, and you know sort of circle geometry and circle theorems, the thing that really struck me is P here, the same length is coming out to each of the other sort of points, but it's the same length, and that to me just screams, well, it's a radius. It's a radius. And when so if you looked at the circumcircle of QRS, P would be the center. Okay, and there's a really nice result, sometimes called the Star Trek theorem. But if you have a chord subtended by an angle at the center, so the angle coming from the center for the length QS, we know that's 60 degrees, then if that chord is subtended by a point on the circle, if we call this, if we call the angle at the point on the circle X, then we get 2X here. So that tells me that the angle I'm looking for must be a half of the 60, 30. So it's an interesting little circle geometry way to see it. I don't think many people will go that approach, because I think it's a little more friendly just to be chasing angles around a bunch of triangles inside our diagram. But either way, 30 is going to be our answer, so that finishes off question 15 quite nicely. Up next, of course, question 16. I'll see you there.